Hello everyone, welcome to our channel. In the last two sessions, we have discussed design of compression members, that is column and strut. In this session, we will discuss the column bases. Now, this is a column. See, the load is applied here. This is the column and this is the base plate on which the column is resting, and this is the concrete block above which this base plate is resting, and this is our soil below. The purpose of column base is to transfer the column load to the foundation, which in turn transfers the load to the soil. As the transfer of load is from the steel column to the steel base plate resting on the concrete block, the base plate requires a larger area to distribute the load on the weaker section of concrete. There are different functions of the base plate: to transmit the column load to the foundation, to reduce the stresses and distribute on the foundation. Then we have different types of column bases: the slab base, the gusseted base, the pocket base. In this session, we will discuss the design of base plate. Let's first see the design steps. In step 1, we have the properties of the section from the steel table. In step 2, we find out the bearing strength of concrete, represented by W, which is equal to 0.45 FCK. In step number 3, we'll find out the area required, capital A, which is equal to load by bearing strength. Here this load is our factored load PD by bearing strength. Then we'll provide 50 mm on each side, keeping the section at the center of the plate, A equal to B equal to 50 meter. This thing I'll show you with the help of a diagram. See here, this is our column and this is our base plate. So this is the height of the column and this is the width of the flange. Then on these two sides we have taken this part as A, from the end of this flange to this base plate. Again, similarly, this is BF and these two parts we have taken as B. So this is our base plate. The total length is L. So this L is A plus H plus C, that is H plus twice A. And the breadth is B plus BF plus B, that is BF plus twice B. That means we have taken the column at the center of the base plate and these are the ends. So the meaning of this: provide 50 mm on each side, keeping the section at the center of the plate, means we have kept the column section at the center of the base plate, and this AB we have taken as 50 mm. Then in step number 4, we have the size of plate. That means the length is equal to H plus twice A, breadth is equal to BF plus twice B, which I have just now shown you in the figure. Then in step number 5, W equal to PD by length into breadth. This is the bearing strength. PD is our factored load, length and breadth, which we have found in step number 4. Putting the values, we'll get the value of W and it should be less than our bearing strength, which we have obtained in step number 2. If it is less, then our design is safe. Then in step number 6, we'll find out the area provided. That means we'll find out the area equal to length into breadth, which we have found out in step number 5. And it should be greater than our required area, which we have found out in step number 3. Then in step number 7, we'll find out the thickness of the base plate as per clause 7.4.3.1 of IS 800-2007. It is on page number 47. So thickness of base plate, it is represented by TS, which is equal to root over 2.5 W into A square minus B square gamma MO by Fy, and this TS should be greater than TF. TF is our thickness of the flange. So this we will obtain, this gamma MO will obtain from table 5 of clause 5.4.1 of the IS code, and we know it is 1.10. And this W we got in step number 2. AB we have got, Fy is our grade of steel. So putting all these values, we'll get TS and it should be greater than TF. Then we'll provide a base plate of size L into B into TS. That means length, breadth, thickness. Now let's see this with the help of a numerical. Design a base plate. It is clearly mentioned in the question to design a base plate for an IS HB 350 at the rate 72.4 kg per meter. This is the section which is given to us to carry a factored load of 1200 kilonewton. The factored load we always represented by PD, so it is given as 1200 kilonewton, which is equal to 1200 into 10 to the power 3 Newton. The grade of concrete is M25, so FCK it should be 25 Newton per mm square, and grade of steel is Fe250, that is Fy is 250 Newton per mm square. Now section is this. So in step number 1, we'll find out the section in the steel table. The section is ISHB 350 at the rate 72.4 kg per meter. The required data are depth of the section H, width of flange B, thickness of flange TF, thickness of web TW. So for this, just go to table 4 of your steel table and you will see this is the I section which is given. Now our section is ISHB 350. These are two 350 and it is given 72.4 kg. So this is our section. Now see what we require. We require this depth of section, width of flange, thickness of web. So these are our required data. We'll write this in our copy and the units are in mm. So these are the required data which we have written from the steel table. Then in step number 2, we'll find out bearing strength of concrete W 0.45 FCK. We'll get it as 11.25 Newton per mm square. So it is done correctly here by taking 25. So you just make the correction here. Then in step number 3, we have the area required which is equal to load by bearing strength. We'll put the values and then we'll get the area. So we'll get the area as 10667 mm square. Then we'll provide 50 mm on each side, keeping the section at the center of the plate. So A is equal to B equal to 50 mm as I have shown you in the design steps. Then in step number 4, we'll find out the size of plate. L equal to H plus twice A. H is the depth which we obtained from the steel table and this A we have taken as 50. So we'll get the length as 450 mm. Then in finding out the breadth, B equal to BF plus twice B. BF we have got from the steel table and this B is 50. Putting all the values, we'll get the value of B as 350 mm. Then in step number 5, we'll find out W equal to PD by L into B. PD we know, L into B means this L into B. We'll get the W as 7.62 Newton per mm square, which is less than the W bearing strength which you have obtained in step number 2. So our design is safe. Then in step number 6, we'll find out the area provided. So area A equal to L into B, 450 into 350. This one 450 by 350. Now, so it is equal to 157500 mm square. This is greater than the area which we have obtained in step number 3. Then in step number 7, we'll find out the thickness of the base plate as per clause 7.4.3.1 of the IS code. Page number is 47. So this is the formula. We'll put the values here and we'll get the thickness of base plate TS. W we have got, A, B is 50. Then Fy is the grade of steel 250. Now gamma MO, this will get in table 5 clause 5.4.1 of the IS code. This is your clause 7.4.3.1 of the IS code. So this is the formula. Now this is your table 5, the partial safety factor gamma MO. Resistance of member due to buckling gamma MO is 1.10. I have shown you this in the column and strut part also. So putting the values, we'll get the thickness TSS 12.11 mm. This is greater than our TF which we have obtained from the steel table, that was 11.6 mm. That means our design is safe, so we can provide a base plate of size L into B into T. Now this L is our length, that is 450 mm, B is the breadth 350 mm and TS is our thickness 14 mm. Why we have taken 14 mm? Because we got TSS 12.11 mm, so we have taken a slightly greater value. So and this L and B we have already got. So I'll show you the figure now. So this is our column and this is our base plate. Now see, the H is 350, then A is 50-50 on both the sides. So the total 50 plus 350 plus 50 is our 450. So the length of the base plate is 450. And this side, the width of the flange is 250 and B is 50-50. So if we add 50 plus 250 plus 50, we will get the breadth as 350 mm. If you have any doubt, refer to the mail ID given in the link below. You can also refer to our Facebook page, that is Easy Tutorials. Link is provided in the description box. So this is the end of today's session. Thank you very much for watching the video. If you liked the video, don't forget to turn the black thumb blue and also do subscribe to our channel for further notifications.